Welcome students, this is the continuation of motion chapter. In the previous class we have learnt about speed, velocity and acceleration. Now we are going to learn about graphical representation of motion along a straight line, that is distance time graph, speed time graph and velocity time graph. In graphical representation, by plotting the distance, displacement or speed or velocity on a graph helps us to understand certain things about time and position. First one is distance time graph for uniform motion. So consider the table which shows the distance walked by a person at different times. That is, for 5 minutes he walked 500 meter, then for 10 minutes 1000 meter, then 15 minutes 1500 meter, then for 20 minutes 2000 meter, then for 25 minutes 2500 meter. So this table shows the distance walked by a person at different times. If we plot a graph between this distance and time, it would be as shown in figure. So a graph is drawn by taking time along x-axis and distance along y-axis. The graph is known as distance time graph. Distance and time. In this graph, what we get by plotting the values, we get straight line. So the person covers equal distances in equal intervals of time. For example, for 500 meter 5 minutes, then for 1000 meter 10 minutes. So what we concluded that he walked at a constant speed. That is, speed is equal to distance covered by time taken. So when we take a slope for this straight line, we get ABC. So in this slope, BC by AC is equal to, so from the graph, BC is the difference between 2000 and 1500 is 500. So BC is equal to 500. Divide by then AC. What is the AC value? The difference between 20 minus 15 is 5. So 500 by 5 is equal to 100 meter per minute. So this is the speed of the person. So steeper the slope, the greater is the speed. Let us take a look at the distance time graph of 3 different persons: Akash walking, Vignesh cycling and Kanishka going in a car along the same path. So we know that cycling can be faster than walking, and a car can go faster than a cycle. So the distance time graph of the 3 persons is shown in the graph. The slope of the line on the distance time graph becomes steeper and steeper as the speed increases. So from this, we know that steeper the slope, the greater is the speed. Next one is distance time graph for non-uniform motion. We can also plot the distance time graph for accelerated motion, that is non-uniform motion. This table shows the distance travelled by a car in a time interval of 2 seconds. So every 2 seconds it covers the distance 1 meter, 4 meter, 9 meter like this. So for first 2 minutes the car covered the distance of 1 meter. Then for next 2 seconds, that is for 4 seconds, the car covered 4 meter distance. Then for 6, 9. Then for 8 seconds, 16 meter. Then for 10 seconds, a car covered 25 meter distance. If we plot a graph between the distance traveled and the time taken, so it would be shown in the figure. So that is, in this graph, the graph is not a straight line as we got in the case of uniform motion. So here we get straight line. But in non-uniform motion, it is not a straight line. So this nature of the graph shows non-linear variation of the distance traveled by the car with time. So thus the graph represents motion with non-uniform speed. So here the speed varies. So the motion of the car is non-uniform motion. That is non-uniform speed. By comparing the graph, distance time graph for uniform and non-uniform motion. So for uniform motion, we got straight line. So it is uniform speed. But in non-uniform motion, we got non-linear variation. That is, the graph is not a straight line. So this represents motion with non-uniform speed. So students, hope you all understood about distance time graph for uniform and non-uniform motion. Thank you.